Alright, welcome to the statistics lecture. So, statistics. Statistics is a wide field that studies different ways to collect, analyze, and interpret data. Alright, so we're going to look at what is an experiment versus a study. These are two different types of ways that the data is collected. So, studies are often done over a period of time. Let me go ahead and write that in. Where the researcher collects a set of responses or variables and records the result. Experiments are when the researcher picks the variables and the experiment is controlled so that all variables are kept as similar as possible throughout the experiments. In an observational study, you are not controlling any of the variables. So you can only say that your results are associations, since we didn't control any of them. Okay, so if you have an observational study, the only thing you can say when you announce your results is that there was an association. In an experiment, you control the variables. So, results there can be conclusions of causations between the variables in the experiments, which means you can say that you have a conclusion of causation. Let me go ahead and highlight that one actually. Okay, so for example 1, label the following as an observational study or as an experiment. So we have 3 different studies here. A study is conducted to investigate the relationship between owning pets and happiness. 100 subjects are randomly selected. They are given a questionnaire that asks whether they own a pet. Then the subjects rate their happiness on a scale from 1 to 10, 10 being extremely happy. So I like to ask myself, did the researchers control anything here? And no, it's all random. They just randomly picked subjects and they're just trying to see if they can find any form of associations, as we noticed before. Okay, so this one is actually just going to be, let me change pen here. This is just an observational study. Alright, B. A researcher randomly creates 2 groups, A and B. Group A is assigned to exercise. Group B does not exercise. After a set amount of time, the researchers record the amount of exercise and the number of colds for each person. Then they compare their findings from group A and B. Alright, so this one, they are controlling variables. They create a group and ask them to do something, and then they create another group and ask them to not do something. So they're doing a lot of controlling in this one. So this is actually an experiment, or an experimental study. Alright, C. A researcher randomly selects a sample of subjects. They record data for each subject on the amount of exercise and colds for last year. Then compare the amount of colds from the groups that exercised and from those that didn't. Alright, so this one sounds a lot similar to B, except here they aren't actually asking them to exercise or not. They're just seeing if they did or they didn't. They're not controlling anything, they're just observing. This one is once again an observational study. Okay, so another thing we want to look at is population versus sample. In statistics, this is often important, the differentiation between the population of something and the sample. So there's a difference in calculations depending on whether your data is of the entire population or just from a sample of the population. So a population is the entire group that you want to draw a conclusion about. Okay, notice it's not necessarily people. And a sample is a small group from the population that you take the data from. And please note the sample size is always smaller than the population. Okay? So if you think about it, if this is the population, your sample sizes, you could take multiple different sample sizes. You could take this sample size, or this sample size, or this sample size, but they're always going to be smaller than the population. Okay? And because they're smaller, our calculations would be a little different. So it's always good to note when you're working on something whether or not you're looking at the population or the sample. Alright. So for statistics, that's always a killer word to say, the measures of central tendency are one thing that's really important. Okay, so measures of central tendency are the averages. Okay, so there are three common measures of central tendency, or averages, that we use in statistics. The mean, denoted with either x bar or this is mu. I think it's miu though. I always just use like a cat meow. But that's mu, the Greek letter. So the mean denoted mu is when you add up all of your data points and then divide by the number of points that you have. Note, we denote the mean by x bar if we're looking at the sample size, and we denote the mean by mu if this is for the population mean. Okay? Once again, that distinction between population and sample does come up. Okay, example 2. Find the mean of the set of data 2, 5, 7, 8, 9, and 12. So how do we find the mean? Well, we add all these up. So 2 plus 5 plus 7 plus 8 plus 9 plus 12. And then we divide by what? Well, by the number we have. We have 1, 2, 3, 4, 5, 6. Divide by 6. Okay, go ahead, pause the video, try to calculate that by yourself, and check in with me in a second. Alright, so finding that, we get about, well, we get 43 divided by 6, which is going to be approximately, let's go ahead and round to the hundredths place, since they don't tell us what else, 1.7. Okay, so I'm going to go ahead and assume that because they want us to just find the mean of these numbers, they actually didn't tell us, but I'll just go ahead and assume here that I wanted the mean for this group. And I'm going to call that the population. So I will use mu. If that was not the population and just a sample, then we would use x bar equals 7, approximately 7.17. Once again, population, sample. The next thing after mean is the median. The median, denoted x tilde, so the little squiggle line up there is called tilde, is the middle number when you are organizing your data from smallest to greatest. If there is no middle number, you find the median by taking the average of the two middle values. So example 3, find the median for the sets of data. Well, when I look at A, they're all out of order, so what I'm going to do is first set them up in order. So I see 7, and then 8, what's next? 13, 14, 21, 24, and 36. Alright, let's see. What's the middle number here? 1, 2, 3, 4, 5, 6, 7. 7. So 4 is going to be our middle number. So my median, x tilde, is 14. Alright, so for B, let's go ahead and once again set this up in order. So we have 6, 7, 8, and then 10, 15, and 20. Let's count how many. 1, 2, 3, 4, 5, 6. Oh, there's only 6, so there's no middle number. What do we do? Well, we'll just take the average of the two center numbers. So taking the average, we're going to do 8 plus 10 and divide it by 2. So 8 plus 10 is going to be 18. 18 divided by 2 is 9. So x tilde is 9. Alright, so two different ways to find the median. One, if you actually have a middle number, you just pick that one out. Second way, if you don't actually have a middle number, you take the average of the two central values. Mode. So the mode is the number that occurs the most often in a set of data. Note, if none of the data points appear more than once, then there is no mode. Okay, so sometimes you can answer none for mode. Example 4, find the mode for the sets of data. If there is no mode, state no mode. Alright, so what I'm going to do is see if there are any repeats. So let me just go ahead and write down the numbers I see. Let's see, so 2, there are no repeats in 2, so let's cancel that out. 3, there are repeats. We have 1, 2, 3. So we have 3 threes. We only have 1, 2. Let's see. And then we have 2 5s. 1 6. 1 8. And 1 9. So the mode, the one that appears the most, is going to be the 3s, because that has the most number of times that value appears. So the mode is 3, the one that appears the most. Alright, go ahead and pause the video and try to check out what the mode is for B. Okay, so hopefully you've tried to figure that out by yourself. Now let's see. 15, we only have 1. Let me just start with the lowest one, actually. We have 1 12. Then we have 1 13. We have 1 14. We have 1 15. 1 17. And 1 19. In fact, we don't have any repeats at all. So the answer here would be no mode. There is no number that appears most often. They all appear only once. Alright, let's take a look at C. Go ahead, pause the video, try this one by yourself as usual. Alright, so hopefully you've paused it. Let's see. We have 1 7. That looks pretty bad. 1 7. 1 9. 1 10. 2 12s. 1 13. And 1 15. Okay, so the one that appears the most is the 12s, which means my mode, or the mode, is 12. Alright, let's go ahead and move on to example 5. So a litter of 18-week-old golden retriever puppies came in to get their shots, and you weighed each of them. There were 8 females weighing 5, 6, 8, and 4 pounds, and 3 males weighing 8, 10, and 9 pounds. Find the average and mean weight for the female puppies. Alright. So this was actually supposed to say the mean, the median, not average, they're all averages. Okay, so find the median and mean weight for the female puppies. Well, the female puppies, let me just go ahead and put these in order for their weights. We have 4, 5, 6, and 8. So, for the mean, we're going to go ahead and just treat this as the population, because we're looking specifically at these puppies. We're not looking at all puppies in the world. So just go ahead and say the mean is going to be, so let's add all these up and divide by them. Well, we have 4 puppies. It's not supposed to be mu bar, it's just mu. Okay. Okay, so 4 plus 5 is 6. Let's see, 4 and 6 is 10, 8 and 5. Okay, we're going to get 23 over 4. And then that is going to equal approximately, let's go 5.75. Actually, that's ends there. So equals 5.75 pounds. So that's the mean weight. Now let's go ahead and find the median. So the median, remember, is the middle number. But when I look at this, there is no middle number. So I need to go ahead and take the averages of those guys. X tilde. And divide by 2. So X bar, X tilde. That's going to be 11 divided by 2. And 11 divided by 2, let's see, 5.5. Alright, so the median is 5.5 pounds. Let's go ahead and find that for the weight of the male puppies. Alright, so the male puppies, we have 8, 9, and 10 pounds for the males. So let's do the mean first. That's going to be 8 plus 9 plus 10 divided by 3. because there are 3 weights we're looking at. Then that's going to be 27. And 27 divided by 3 is going to be 9. So the mean weight is 9 pounds. So let me go ahead and put pounds there. Now let's go ahead and find the median. Hey, look, we actually have a middle number 9. That works. So x tilde is 9 pounds. So the male puppies are bigger than the females, pretty much most of the time. Hey, look. Actually, our mean and our median happen to be the same here. Mean and median for this one are a little different. And that's why we have 3 different ways of looking at averages, because depending on how you look at the data, often your answers might be different. And this is something to keep in mind whenever you read any form of statistics or data found in any sort of a study. Just be aware of how they collected their data and what they were drawing their answers off of, because the way you look at data can change your answer. Okay, find the mode weight for all 7 puppies. Okay, mode for 7. So the weights we have, just going to go ahead and copy down the female weight and then plop in the male weight at the same time. And looking at these, I notice the only time we see a double is with the 8. So we do have a mode. The mode weight is 8 pounds. Okay, so now we're going to look at measures of variation. So we had measures of central tendency, which are our variables, which were our averages. Now we're looking at measures of variation. So measures of variation describe how the data is spread out. We're going to look at 3 different values of variation. So there is a thing called the range. Now the range is the difference between the smallest number in your data and the largest value in your data. So let's look at the example. Find the range given the following set of data. So I'm going to go ahead and find the smallest number, which would be 2. And I'm going to find the largest number. That would be 11. So now I want to find the difference between these. Difference is subtraction. 11 minus 2. That's going to be 9. So my range is 9. Okay, so next we have variance. The variance tells how much the data varies around the mean. It tells us if the data is grouped closely to our mean value or more spread out. The variance is nice, but normally what we use is something that's tied to the variance, which is called standard deviation. You may have heard this word before. So the standard deviation denoted sigma, or S sub x, so that's sigma or S sub x, is the square root of the variance, most often denoted as sigma. It is also a measure of how spread out the data values are. So notice sigma is the population's standard deviation and S sub x is the sample standard deviation. So sample versus population once again. So below are the formulas for finding the standard deviation. Okay, so if we're just looking at the sample, this is how we'd find it. If we're looking at the entire population, that's how we would find it. And please so note that the standard deviation is the square root of variance, which is what we were just looking at. So this formula here is how you find variance, and then taking the square root of it is how you'd find your standard deviation. But most of the time we just focus on standard deviation. And in this class we're pretty much going to focus on sample standard deviation, so we'll be using this formula most of the time. So before we get into that, we need to look at what summations are. You may or may not have seen this symbol before. That is called a summation, or the sum. So this is denoted when you add up all of the values given to your variable inside the summation. So for example 7, let's look at what this means. We want to determine the sum of x squared, and we are given these values for x. So what I want to do, I'm going to be adding up each of these values squared, because that's what I'm told to do with those values. I'm told to take them and square them. So 2, and I'll square it, and then I'm going to add to that 3. Remember, I was told to square it, plus 6 squared. Okay, so that's the sum, so let's say I have 4 plus 9 plus 36 And then adding that up, that's going to be 13 plus 36, so 49. Okay, so the sum of x squared is 49. Alright, so here's our next example. 4 cats came in today for checkups. Their ages were 6, 2, 3, and 1. Find the standard deviation of their ages. Okay, so we're just going to go ahead for now and focus on using sample standard deviation. Okay, so if you take a statistics class, you'll go ahead and work more on problems where you have to figure out the differentiation between population and standard or sample. But for now, we're just introducing you to the basic idea, so I'm just going to stick with having us use this formula. Okay. So to find this, what I want to do, I need to first notice what are the values in here. We have xi, and those are the data points. We have n, which is the number of data points. And then we have x bar, and that is my mean. So I need to go ahead and find each of those to plug into my formula. Alright, so what is my mean? Well, my mean, remember, you just take all your points, add them up, and divide by the number that you have. So it's going to be 12 divided by 4, which is going to be 3. Alright, so we found that. And then my n value, the number of data points we have, which is 4. So n is 4. Now we just have to go ahead and fill in all the summations, and then we can find our answer. So we needed to do this inner part first before we go on. Okay, so this is saying, take all my values, subtract the mean from it, then square it. So the first one we have, I'll go ahead with the 1. So 1 minus my mean value, which is 3 squared, plus, okay, so that was 1. I'll go ahead and just use red here. And then we're going to take the 2, subtract the mean from it, and square it. And then take the 3, subtract the mean from it, and square it. And then finally, add that with the 6, subtract the mean from it, and square it. Okay, because remember, our formula tells us to subtract the mean from our value and square it. So then we have negative 2 squared, plus 2 minus 3, negative 1 squared, plus 3 minus 3, 0 squared, plus 6 minus 3, 3 squared. So that's me 4 plus 1 plus 0 plus 9. 5 plus 9, which is going to equal 14. Alright, I didn't leave a whole ton of room here for my actual standard deviation formula. That wasn't entirely smart. Let's go ahead and box out some room here. Not the neatest of problems right now. So I'm going to go ahead and rewrite my formula. S of x equals the square root, actually let me rewrite that, of, okay, so we found our summation, which was 14. And then we did n minus 1, so n was 4. Minus 1 from it. So we get s of x equals the square root of 14 divided by 3. Okay, so what is 14 divided by 3? And then we're going to take the square root of that. This is going to be an approximation. 2.16. Let's go ahead and just round to the hundredth unless we're told otherwise. So, the sample standard deviation here, since we're talking about the sample, if it was a population, we'd be using the population formula. Right there. So standard deviation. 2.16. All right, so let's take a look at the normal distribution. So the normal distribution, or the bell curve, is the distribution that occurs naturally in many situations. So the bell curve is symmetrical. Half the data will fall to the left of the mean, and half the data will be on the right. The total area under the bell curve is 1. Okay, very important to know this. Total area is 1. So the bell curve I'm talking about is something like this. Might look a little neater than that, actually. So we normally have our mean listed out, and then the total area under this equals 1. And half of our data is on this side, and half of it is on this side. Okay, so oftentimes you might see this example in the grades for a class or something. You might have a certain amount of students who tend to have, let's see, 70%, so that's going to be around the mean, 70%. Students that are in the 90s might be higher up here, and students that are in the 30s or something might be in the lower end of the data. Alright, so the empirical rule tells you what percent of your data falls within a certain number of standard deviations. Here's what standard deviations come in. Away from your mean. So the empirical rule, real quick, I sort of skipped over this name here. It also might be called the 68, 95, and 99.7. Important numbers to remember. What this says is that 68 of your data falls within, since it's the first number, 1 standard deviation away from the mean. So if I was to draw this out on my little bell curve, 68% would be 1 standard deviation away from my mean. 1. Then, 95% of your data falls within 2 standard deviations away from the mean. So we have 2 standard deviations. So then that would be 95% of the data. And then 99.7% of your data falls within 3. Let me write that out. 3 standard deviations of the mean. So let's go ahead and draw the 3. So this was the 99.7, 95, and then 68. Okay, so sort of a basic run over for 68 is 1 standard deviation, 95 is 2, and 99.7 is 3 standard deviations away. Alright, so we're going to go ahead and play around with the bell curve and the standard deviations with the 68, 95, and a 99.7 rule. For example 9, given that you have a mean, mu, equal to 35, and a standard deviation, sigma, equal to 1.2, find the empirical rule values for the 3 standard deviations away from the mean. Draw the bell curve and label with the mean and the standard deviations. Alright, so let's see, here's a bell curve. Well, my mean, the middle value, is 35. So now what I have to do is find the 3 standard deviations away. The simple, or the main ones, 68, 95, 99.7. These 3 pretty much always stay the same. Those are going to be the 3 main ones you tend to look for. So I'm going to go ahead and just label out my 1 standard deviation. So how do we find these? Well, what you do, for the 1 standard deviation away, you just take your new value and you add or subtract your standard deviation. Okay, so mu is 35. I'll add my standard deviation, which is 1.2, and I'll get 36.2. So this value over here, 36.2. That's 1 standard deviation away from my mean. Just 1 standard deviation. And then the other way, I'm going to subtract the 1.2 to find the other side. So that's going to be 33.8. Alright, so next we're going to go ahead and find the 2 standard deviations away. So that's, the formula for that is going to be mu plus or minus 2 times your standard deviation. Okay, so we have 35 plus 2 times 1.2. So that's going to be 35 plus, and then let's see, what's 2 times 1.2? So 2.4 plus 35, 37.4. So that's the next one. So that's going to be 2 standard deviations away. And the answer for that was 37.4. So this is 2 standard. Let's go ahead and find the other side, the other 2 standards. That's going to be 35 minus 2 times 1.2. And that's going to be 32.6. All right, let's go ahead and find the last one, 3 standard deviations away. That's going to be mu plus or minus 3 times sigma. So we have 35 plus 3 times 1.2, and then 35 minus 3 times 1.2. Okay, go ahead, pause the video, calculate those out, and check back in with me in a second. Okay, so 3.6 plus 35 is going to be 38.6. And then 35, so 3.6 and 35, going to be 31.4. Okay, so we found our 3 standard deviations away. Go ahead and label those. Alright, so there we go. And what does this mean? Well, remember, this is talking about the percent of the data that falls in between here. So if I was asked, what percent of your data falls between 33.8 and 36.2? We would say, well, those numbers are right here, 33.8 and 36.2. So you would say, since this is just 1 standard deviation away, that this is 68%. So 68% of my data falls in 1 standard deviation, or 68% of the data falls between 33.8 and 36.2. If I asked you, what percent of the data falls between 32.6 and 37.4, you would say all of this data falls between that, and all of that is 95% of the data. But what if I asked you, what percent of our data is less than 31.4? How would I find that? I want this area here. Well, that's not part of the normal standard deviation area. Well, remember, what we know is that the whole area under this curve is 1. Okay? So the whole area under the curve is 1. And what I'm going to do is I'm going to take away this area here, which I know that this is 99.7. So 1 minus 99.7. And what's that going to be? Well, 1 minus 99.7 sorry, we're supposed to put that in as a percent, because that's a percent. So it's supposed to be 1 minus 0.997. Or you could have looked at it, if we're looking at 100%, it's 100 minus 99.7%. So 1 minus 0.997 is going to be 0.003. So that gives me those outer edges. Okay, because we took away that inner percent, and now we're just left with these outer edges here. But I only want half of that outer edge. I want this half. So I'm going to divide the 0.3 by 2, because I just want 1/2. So divide that by 2, and we will get 0.0015, which would be the area of this little area. And if I wanted to make that as a percent, that would be 0.15%. So my answer would be 0.15% of my data falls below 31.4. Okay, so that is it for our simple overview of statistics for this class. The homework is in the La Lima page. Remember, you don't have the McGraw-Hill Connect homework for this section because it's not part of our book. So the homework is posted on La Lima. Please email me if you have any questions.